Hi, chemistry. I want to talk to you about how compounds form from elements in predictable ways. So, this is very related to what we're doing as we work to form ionic compounds, to form covalent compounds, looking at different types of ionic and covalent compounds like bases and acids. Um, a lot of what we know is based off of the work of a couple scientists in the past. And these scientists actually came to the conclusions that we are learning through really impressive ways. So, we've talked about why ionic compounds form and how they are driven by electrostatic attraction, and they form in ratios depending on their charges. We have talked about why covalent compounds form and how they are driven by the octet rule. So obtaining, sharing electrons until their outermost energy levels all have 8, or in the case of hydrogen and helium 2, right? So they're driven by the octet's stability. And these compounds we write either in lowest ratios in the case of ionic compounds, or in the case of covalently bonded compounds that exist in a lattice, like silicon dioxide, right? Or we write these compounds to represent the atoms that actually make them up in the case of discrete covalent compounds. So we have talked about all of these things, but how do we know this? Well, today we have a lot of different technology like electron scanning microscopes, photoelectron spectroscopy, mass spectrometers. So we have a lot of equipment that can give us insight into molecules and compounds. But when these molecules and compounds were first being discovered, the scientists did not have any of this technology. And so a lot of these conclusions were initially drawn by really carefully weighing or massing compounds before and after a reaction, which is super impressive. If you can imagine obtaining a balance, which is probably something like a triple beam balance, something that is balanced against measured amounts of metal, and coming to the conclusion that atoms exist and they form compounds in predictable ways. I mean, that's incredible. So a lot of this was done by a couple different people, but one of the big guys was John Dalton. And John Dalton ended up writing a couple different laws. He wrote 5 different postulates to describe atoms. Some of those postulates we hold to be true today. Some of those postulates were modified a little bit as we got more information. And then he also wrote a couple laws that governed the formation of elements, which are still true today. So he literally just took different elements. Like on the screen here, I have an example. This is a pile of carbon, and this is liquid oxygen. Now, I don't know if he had liquid oxygen or not, but oxygen is easily obtained from air. So we had a couple different compounds, and he would combine them and let them react and see what happened. And he would actually mass or weigh the reactants, and then he'd let them react, and he would mass or weigh the products. And what he found were these laws that governed how atoms combine to form compounds. So, for example, if we look at carbon and oxygen, like we have on the board, so if we have 12 grams of carbon, it's going to react with 16 grams of oxygen. And when 12 grams of oxygen reacts with 16 grams of 12 grams of carbon reacts with 16 grams of oxygen, what you get is is a compound made of one carbon atom and one oxygen atom. Now, his measurements weren't quite as nice and pretty as these very even numbers were, but basically he did a lot of work with ratios. He looked at ratios of the masses that he combined, and he found that carbon and oxygen would react in this 1-to-1 ratio of 12 grams to 16 grams. So he concluded, well, 12 grams must be one carbon, 16 grams must be one oxygen, right? But another interesting thing he found was that carbon and oxygen didn't always react in 12 to 16 gram increments, but whatever they reacted in was always a multiple of this. So for example, you could have 12 to 16, or you can have a reaction of 12 to 32. And we know that the ratio of 16 to 32 is just double what 16 is, right? So carbon and oxygen will form with 1 unit of carbon to 1 unit of oxygen, the unit being an atom, as we know today, or 1 unit of carbon to 2 units of oxygen, or 1 unit of carbon to 3 units of oxygen. So carbon and oxygen always react in these ratios. Now, it's not surprising to us that that occurs, right? Because we know, well, of course, you're going to get 1 carbon atom to 1 oxygen atom, or 1 carbon atom to 2 oxygen atoms. Of course you would do that. You would never have a 12 grams of carbon reacting with 8 grams of oxygen, right? Because 8 grams of oxygen would be half of an oxygen atom, and you can't have half of an oxygen atom. Of course, that's logical to us, but it wasn't logical back then in John Dalton's time. John Dalton was trying to convince people that atoms existed and they were indivisible. Now, technically they're not indivisible, but you can't divide them using a chemical reaction, right? You have to divide them using a nuclear reaction. So he was trying to convince other people that this was true, and so these ratios that he found, which govern the predictable ways in which compounds form, was law-changing. So let me show you the names of the laws just for fun. Okay, so the laws that he wrote were called the law of definite proportions and the law of multiple proportions. I've basically described them to you. If you want to know more about them, you can read about them in 9.5. The section in 9.5 is actually super short. I don't know why I can't draw a line with this pen. The section in the book is really short. It's like a page or two that talks about these 2 laws. But these 2 laws are a little tricky to wrap your brain around. You have to really embrace proportions before you read this section. Maybe try some of the calculations yourself instead of trusting the calculations that the book does for you, and try the example. So if you want to learn more about it, you can read 9.5. But I've basically described to you the idea behind these 2 laws. Basically, he concluded using masses that atoms exist. Those masses were his evidence for the existence of atoms, and atoms can only combine in whole number ratios. You can never combine half an atom, right? So read more about it. Let me know if you have questions on this. I will talk to you in class.